Hello explorers and welcome to another video. It's springtime, spring cleaning and Java 12. So Java 12 will be released in the middle of March at 2019, March 19. So it's pretty soon. So I'm going to go through what's in the new release and what you can expect of it. And as they release Java in bite size every 6 months, there will not be that many new features, but there will be iteratively updating the language and adding new interesting stuff. So first off, we have Shenandoah. I'm not really sure how to pronounce this word, but it's a low pause time garbage collector. So it's all about spring cleaning, removing garbage. And this is experimental. It's not something that you want to run in production, but it's an interesting thought. It was from a paper written sometimes 2016, I believe. And this paper said that you could have a garbage collection that could be in a set amount of time independent on how large your actual memory is. And that's done by using a lot of threads. So if you have a machine with a lot of threads, a lot of CPUs, you can use more CPU power in order to have more low latency garbage collection. And this is done by adding some pointers to every part that is used as a collection in Java. So every little class has its own little pointer, and every large data structure have a pointer. And these pointers are updated and looked at on the fly in other garbage collecting threads. And then when you need to actually do garbage collection, they can actually remove the data and move the data to the right position just by moving the data as a shadow copy and then moving the pointer. The part that is a little bit hard is that you need to actually have a view of all the objects in your memory. So you need to do one sweep where you actually figure out how your tree looks. And that will be something that is stop everything and sweep through. But that's a really fast operation, so it will be very low pause time, this garbage collection. So it's an interesting thought. They have a first implementation of it as experimental, so you can run it and try it. And if you really need those really low pause times, this could be a good garbage collector for you. But it requires more memory or more space, and it requires also more CPU. So it's CPU heavy and memory heavy, but low latency. So then we have Microbenchmark. I looked into this a little bit. They talked a lot about setting up a test suite so you can actually test the performance of Java. And they wanted to test it against Java 11 and so on. So they have created some Microbenchmark suites so you can actually see progressively how the platform is changing and if the language goes forward and it actually gets better over time, it gets more performant and so on. So this is an interesting project, and they have the first implementation of most of the core functionality. At least they have more to implement, but they thought that at least the first part was done, so they release it here. Switch expression, this is a new preview, so it's also something that you should not run in production. It's very similar to how Kotlin does switch, or in their case they have another name for it. They call it when. And then they have a lot of different cases down there, as you have in the switch statement. But we have the classical switch expression, and then we have cases of that switch. But there are similarities. So you can look at an example here. So this is a switch statement over weekdays. You can bunch a lot of values together like this. So you actually have a few different options that goes to one specific implementation. You use this arrow notation to actually show where the block starts. And if you don't have any block starts, if you don't have any of these brackets, then it ends on that line, so you don't need to use breaks and so on. So it makes the code a little bit more condensed, and it looks a little bit better in my opinion. And this is the first step towards to actually create pattern matching switch statements, which is another project of theirs. So it's a really good first step, I believe, and this can be really interesting to use, but it's still a preview, so it's not something that you should run in production. Then we have this JVM Constant API. I read up on this as well, and it's more when you actually need to change your Java classes on the fly. So you actually need to add some information like profiling information, or if you're creating a debugger or something. It's not something that you use when you actually write normal Java code and so on. This is to change constants or get constants in classes when you actually are using reflection and so on. And then we have, this is a very interesting JEP. They actually just removed an implementation. So they had two implementation of the ARM64 port, and one of them became deprecated and is now removed. So now they only have one 64 arch and they have one 32 arch, and the other ones are removed because they are not necessary. It will be less code to actually handle and less repetition when they actually need to implement the language. Then we have default CDN archives and CDS archives. So these are class archives that they actually do compile the classes and then save some information about the running statistics for those classes. So next operation or next run of the JVM will be faster. And this will be for the default classes in the JVM. So when you run your program, it will compile the base classes for you and save that away. So the next time you run, it will be faster. So it will always save and update that information for you. You can also turn on this feature where you save application specific statistics to make the compiler JIT faster as well. But this is for the main Java classes, and it's now turned on by default. So Java 12 will probably see a little bit of a performance boost. And then we have this JEP. This is a little bit of a weird one, but when you have a GC, so a garbage collector like GE1, and that's the one that is default in Java at the moment, it has a collector that collects all the classes and all the objects that it needs to garbage collect. So it needs to throw some classes away. And after it has done that collection, so it knows which batch it should work on, it figures out that this batch is large enough so it will be in my window. So the garbage collector has a time frame where it will work. So it stops the CPU and then does the garbage collection for a set amount of time, and then it should be done with that batch and then goes on. The problem is that sometimes it does the collection, figure out that this batch should be good enough for me to collect during this time, but it realizes when it had done one of these batches that I was totally off. This was not a good batch size, and my next estimate will probably be off as well. So how can I rectify this? Well, I will do it like this. Next time I will garbage collect, I will garbage collect item for item, and after each item I will look and see, should I abort now? And then there will be another thread telling this thread to abort when the time frame is up. This means that this garbage collector will adaptively actually abort when it has too large batches. So it will be more prone to actually be done on time. So you don't have a spike of time where the garbage collector is working. So it tries to keep it to a set time and tries to make the time for each batch to be similar. And this is a step in that direction. And then the last thing is also spring cleaning, working out on the G1 and make the G1 better. And you might have noticed when you are working with garbage collection and you might run out of memory on your device. If you're working on a phone, for instance, and you work with large objects, you will run out of memory sometimes. And one of the problems you have there is that the G1 is not removing the objects fast enough and giving memory back to the system. It actually holds that memory and then removes it at either full GC or at the next run and so on. And that can be really bad for memory constrained devices. So this YEP works at actually returning memory as fast as possible after it has been collected. So this was what I wanted to cover today. I hope that you found this video interesting. I hope that you learned something today. If you have any questions about Java, or if you are excited about the new Java version, if you want to talk about garbage collectors, then leave a comment down in the comment section down below. And if you haven't subscribed yet, please do that. Like the video, share it with your friends and colleagues, and I really hope to see you in the next video.